Howdy guys, and welcome back to Cruiseman's Inventions. Geez, thank you everybody too for all your comments and stuff on the last little generator motor build and so forth. I have a lot of videos, guys. You gotta look me up or subscribe to my channel to find half of my stuff. But there's some interesting stuff on there, and this is another one of those videos. So let's get into it, guys. What I have in front of me, this is kind of a little tribute build that I'm gonna be doing. I'm just going to follow through with and tell you a little bit about what I'm doing and some of these motors and how capable they are of actually running maybe a washing machine motor that's capable of running a washing machine motor, producing way up to 300 volts of AC power. You know, if this window wiper motor was turning a washing machine motor, the 36 pole one, you can look up all the different wiring diagrams on my channel, guys. I have a few, and teaches pretty much all about those and stuff. We have a little DC one here, 250 watt, just a straight out DC motor. Now this here would be great for running something like this. What this here is, guys, is a little tribute to Gerald Marin and some of his free energy devices. Now let's take, is this familiar to you? You know what this is, guys? This is a water pump out of a washing machine. There's the impeller, right? There's the rest of it. Don't need none of that, but what we do need is to take this off or put a small little drive system that we can put this onto or connect it up to another motor like this, right? These two yellow wires are your switch wires. You can just put a switch between those two, and the other two, when it's spun up by this one by a 12 volt battery or a controller from an e-bike, that's a 1000 watt one DC. You can have a potentiometer, like a volume control instead of a throttle. See that there's another two here. That's where you come out DC. Out of those two there, they don't really come out too well. But anyway, I gotta test it. I gotta spin it up, test it, because it could be these two. Who knows? But anyway, the main deal of this is that that's a magnet in there. It's only got kind of two sides to it, and Gerald Marin teaches you a lot about these free energy little motors type of thing. They hold a different resonance, and something I'm eager to tell you about is when I get this going, guys, is I believe that you'll be able to run this off a little motor like this, get it up to speed, draw all the power off here to be able to charge up your e-bike as you're burning along without burning out your controller. You see what I mean? I've had generators and washing machine motors rewired as generators and as a motor at the same time on a drift trike that I built. Now yeah, there's other types of these motors too. Here's one here that's out of a microwave, but that's got no magnets in it. That's more like induction. It's just like a alloy core, and then, you know, it's really this, making that move instead of the other way around won't work. So, but this is different. So I'm eager to find out if when I spin this up, I can actually make my e-bikes work. Just straight off this, no batteries. Because you can't do it off a brushless motor. Well, not none of these anyway, not like the washing machine, and you can't do it off this one either, which is a Kawasaki, out of a 250 Kawasaki bike, that one there. It is 18 poles, and it is brushless, and I just disconnected it from my stereo, just to see if there was sound coming out of it, and sure enough, not overly loud, but clear, but when you spin it, it sort of cuts the sound out, it makes it flicker a little bit, but when it's still, the sound will come out. So anyways, that 18 pole charge coil, it used to be on a bridge rectifier, which actually stalled it. It really stalled it and held it back a lot. There was a lot of residual forces, but anyway, when I took one out of a bridge rectifier out of an alternator, it became much freer. So, and you could hook up the 3 pins and then come out at 2 in DC. So anyway, that's the schematics for that there, 18 pole charge coil. And this is this was actually spun up on a bench grinder. I had it connected to that. Yeah, you could use these as brushless motors as well. I had it running off a controller and 48 volts running a bench grinder. So little things like that if you had no power stuff. So yeah, out of the two phases here, we ordered that full bridge rectifier with the alternator, full bridge rectifier. Okay, that would have come out of probably 3 pins or something, but here we go, that gives you some idea. 2 phases without the alternator, bridge rectifier, came out of that at AC. So yeah, and that's what it spun up to get that. I think you could get it out slower anyways, you know what I mean? You could spin it slower to get that same amount of power out. But this here I was thinking of actually hooking up on one of my bikes and letting that part there spin on the wheel so that it could at least charge up to 48 volts worth of batteries, because it's quite capable of producing that, you see. So yep, that'll be right on scale with charging 48 volts, and their top charge would be exactly that. So if I had that running on my wheel, on my bike, on my e-bike, I could put the charge into at least 4 out of the 6 batteries. Yeah. So 6, I think I got 7 batteries in there because it's actually 84 volts, so it'll at least charge half of them up. Yeah, you can put those on boost converters, or that's bucks converters, or whatever you call them too, and you know. But anyway, what Duramarine was doing with these motors here was actually putting a small 12 volt motor like that up to it, because these spin really fast, and then taking the power out of this and connecting up light bulbs. That's what it's really good for. But I'd really like to do some more tests with it myself and just see how far we can push something like that. I mean, there's not much to it. It's just that magnet with 2 sides spinning around on that little core, and then you've got a coil in here. But look at that, guys, that's something I just spotted. See, that side's really good. Look at that. It's kind of a bit bubbly, so it must have got some heat in there at some stage, but I won't know until I get a piece on there, get it spun up, do some tests with my testing. So yeah, let's go and have a look at my windmill and stuff. This is one of the reasons why I haven't been doing any more washing machine videos, guys. It's because it's up here now. See, and that's my windmill, and my 94 volt generator, 96 volt generator washing machine, 36 pole, is in there out of a smart drive washing machine. That's the one that's in there. None of the ones I got now are stock. They're all being rewired to to all those specs that I have on my wall and stuff. But I'm thinking of pulling this down. I'm thinking of building a whole different generator, and the best kind of generator that you can possibly build is a couple of those washing machine motors, guys. Right, a couple of those washing machine motors, and you have one that's actually rewired to the 12 times 1C, right? And you have that, you rewire that with 28 turns per pole. Yeah, but in the 12 times 1C configuration, and that will make it to where you'd only need a 1000 watt controller, 48 volts, and this thing it'd last for a while anyway. It'd put out a bit of power, turn that just on a trickle, and then on the other end of the shaft would be your stock one, and then you draw power from that. They wouldn't get hot. The only thing that would get hot is the controller, which you might need to put a fan in it, but it doesn't get utterly hot. It's real lightweight stuff. What you're doing by changing the wiring diagram like that, and the wiring thickness, by making it thicker, you're actually downing the ohmage. And by halving that ohmage, you are now creating twice the amount of power out of your controller. You learn that from stereos and stuff. When you join 2 8-ohm speakers together, positives together, negatives together, it does a decrease in ohms. But if they're in series, it does an increase in ohms, see? But you get less power out of your amp, and the sound is a bit more distant. So you learn all that through stereos too. So same deal with these, they're just coils too, So that's something really cool to learn about ohmage anyways, guys. So yep, I'm gonna probably get to now and just sort of get back to this, guys, and send this off to you. So this is what you look for anyway, and I want to know if that, when I spin it up, can run my e-bike controller, whether it'll be a DC one or a brushless one controller, Doesn't really matter. I just want it to run one without batteries. That'll be fun. These are quite capable of 130 volts each, AC, till you put it through a bridge rectifier. Cool stuff, guys. Thank you all for watching. And yeah, the reason why those motors were so noisy in all of those videos that you watch is because of these little motors. But if you had a tape deck one, which is slightly fatter, they're not as noisy. But if you had one that's even bigger again, of an e-scooter, well, that's quiet, really quiet. It's still economical, 24 volts. So, awesome, guys. Have fun. Build, build, build. Woohoo! Cruiser Man out, guys. Thanks for watching. Put a comment in the comments down below if you want. Awesome, guys.